Hello, welcome back. We are going to be working on lesson 2.7, and it's all about absolute value equations and inequalities. So we just looked at the absolute value equation, which is like a V or an upside down V, depending on the transformation. And in 2.7, we're going to look at inequalities. And I want to go over some of the rules here on page 177. So it says rewriting absolute value equations and inequalities. If C is positive, real number, then each of the following statements on the left is equivalent to the corresponding statement on the right. So this is what we did in lesson 2.6. The absolute value of X equals C. And then we know that this is true, that X must equal a negative C or X must equal C. But now we have inequalities. So if the absolute value of X is less than C, then we know that X is between the two. If the absolute value of X is greater than C, then it's either less than the negative or greater than the positive. And then we have expressions that are on the inside. So when it's equal, this is what we did in 2.6. And now we're going to do the same thing with the less than and the greater than, just like we did up here stated. Okay, so we're going to go ahead and put these into practice. And I'm just going to write them here to remind ourselves. So with absolute value, and I'm only doing the inequalities here. And it's anything inside the absolute value. So it actually counts for the one that's the AX plus B as well. So this is a negative C. So X is going to be between the two, or when the absolute value of C is greater, absolute value of X is greater than C, then X is going to be less than a negative C, or X will be greater than a positive C. And that also goes for the same for when it has AX plus B on the inside of here. They hold true. So let's look at number 2. Let's just get started with a few simple ones. So the absolute value of X is less than or equal to 7. So because it's less than, then X is going to be between the two. So that means X is going to be greater than or equal to a negative 7 and less than or equal to a positive 7. And now our rules hold true from when we were solving in 2.6, that we first have to isolate using our rules of solving equations, and we have to isolate the absolute value. So by subtracting 5, we get the absolute value of T is greater than 3. And because it's a greater than, we know that T is either going to be less than a negative 3 or T is going to be greater than the positive. So less than the negative or greater than the positive. So let's look at number 18. Okay. So now we have an expression inside the absolute value, but it's a greater than. So we're just going to put that, the absolute value, we just have to look at that for a minute. And we have to look at, it says solve each inequality. So where is the absolute value of A plus 2 is greater than or equal to a negative 5? Well, remember what we said about absolute value functions. They're always at 0 and above, because nothing negative can ever come out of here. So this could never equal a negative 5. We had a couple of those no solutions in 2.6. But it's always going to be greater than a negative 5. So that means it's going to be all real numbers. And we show that in the interval of a negative infinity to infinity. So that one was nice and easy. this should have been just a single b here. Okay, number 30. So again, we have an expression inside the absolute value. We have to isolate that first by adding 4. So we have the absolute value of 6x minus 1 less than or equal to 6. So it's less than or equal to, and so that means that it's going to be between. So a negative 6 is going to be less than or equal to 6x minus 1 is less than or equal to a positive 6 because it's less than or equal to. And then we're trying to solve that for x. So we're going to add 1 to both sides. All 3 pieces, I should say, all 3 terms. So this becomes a negative 5 less than or equal to 6x less than or equal to 7. And then we're dividing by 6. So negative 5, 6 is less than or equal to x is less than or equal to 7, 6. Okay. I think we're getting the hang of it. I hope so. If not, schedule a Zoom time with me. I'm happy to help. So we have the absolute value is already isolated and it's less than or equal to 7. So we are going to, that means that negative 7 is less than or equal to the negative 3x plus 4 is less than or equal to a positive 7. And so to isolate x, we're going to subtract 4 from both sides. All 3 sides, I keep forgetting. So a negative 11 is less than or equal to a negative 3x is less than or equal to a positive 3. And then we have to divide by a negative 3. And so when we divide by a negative 3, we actually have to flip the signs the other way. Because now this becomes a positive 11/3 and x, and this becomes the negative. And so it's going to be, instead of less than, it's going to be greater than, greater than, greater than, greater than. And you can leave it like this. I like to write my smallest number on the left. So I'm just going to turn it around. This is going to be the negative 9 here. It's going to be less than or equal to x, which is less than or equal to 11/3. Now, the only thing is that all of this will be greater than the negative 9. Let's see here. Oh, that was dividing. How did I get a 9 here? This should be a negative 1, and this should be a negative. That should be a 3 divided by a negative 3. So negative 1. To that, yeah. Sorry about that. That should be a 1, a negative 1. So it's a negative 1. It didn't look right. Thank you. Okay, let's look at the last 2 problems I have for you, or last, I've got 4 actually. Let's look at 44. So we're still solving equations. That's the cool thing, is you're getting lots of practice using all of our solving skills way back from page 110. So 44, it's already isolated and it's a greater than. So we know that 7 minus x is going to be less than the negative of 2, or 7 minus x is going to be greater than the positive of 2. And now I like to keep x on the left. So I'm going to go ahead and subtract 7. And we get a negative x is less than a negative 9. And to get rid of the negative, I'm going to divide by a negative 1. And because I'm doing that, I have to flip the sign. So this becomes x is greater than a positive 9. Okay. And then over here, I'm going to subtract 7. And we get a negative x is greater than a negative 5. And again, I have to divide by a negative 1. And because I'm doing that, I've got to flip the sign. So this will be x is less than a positive 5. So it has to be less than a positive 5 or greater than 9. And they wanted us to graph the solution set. It's always good to see that here. Did they want us to do that before? We didn't do the interval, did we, before? So greater than 9, and it's strictly greater than, so it's an open circle, and less than 5 is an open circle, and it's to the left. And we got to do these on 30. They wanted us to graph that. So that would have been a negative 5, 6, and we would have colored that in because it was including x all the way up to there's 0 and there's 7/16. And that also gets a shaded in circle. The one that's all real numbers up here, sorry about that, number 18, it's all real numbers, so it's everything on the number line. Number 40 was 2 pieces, so we said it's going to be between a negative 1 and 11/3. And that one was using the interval notation, so. Okay. So 48, I wanted to do this one just to remind ourselves of how we can eliminate fractions. So because it's greater than, we know that it's going to be the 3 minus 1/3 x is going to be less than the negative of 1, or the 3 minus 1/3 x is going to be greater than the positive. And so to eliminate our fractions, we are going to multiply all 3 terms or both sides of the equation by 3 because of this denominator 3, it will cancel out. So if we multiply this by 3, it cancels. And so that means we have to multiply the 3 by 3 and we have to multiply the negative 1 by 3. So we get 9 minus x is less than a negative 3. And then we're trying to isolate x, so we're going to subtract 9. I'm going to leave my x on the left. So we have a negative x less than a negative 12. And then I want a positive x, so I have to divide by a negative 1, but we have to flip the symbol. So x is greater than a positive 12. And then likewise on the second piece, we also have to multiply through by 3. And it's not because of this 3 out here, it's because of the 3 in the denominator. So if we multiply by 3, the 3 cancels out of the denominator. So we have 9 minus x greater than 3. And again, we're going to subtract 9. And we have a negative x is greater than a negative 6. And dividing by that negative 1, we have to flip our symbol again. So it's a positive x is less than a positive 6. And if we draw this on the number line, we have 6, and it's an open circle, and it's everything less than that. That's this over here. And then this right here is 12 with an open circle and shaded to the right. Okay, and then our last two, 56 and 70. So 56, again, I wanted to give you practice with a fraction, and it's greater than. So that means 2x minus 5 over 3 is going to be less than or equal to the negative 1/6, or 2x minus 5 over 3 is going to be greater than or equal to the positive 1/6. And again, we have to multiply through by the least common denominator. So the least common multiple or whatever to eliminate our fraction. So if we multiply by a 3, we'll eliminate this fraction, but a 3 would only reduce this to a 3/6, which would be 1/2. So we're going to multiply through by the 6. So we're going to multiply by 6 here and 6 here. So it completely cancels on the right. And then 3 goes into 6 2 times. And then we just have to distribute that 2. So again, we multiplied by 6 because it would both 3 and 6 divided into 6. So we have 4x minus 10 less than or equal to a -1. Solving for x, we're going to add 10. So we'll have 4x less than or equal to 9. And we're going to divide by 4. So x equals 9/4. And we'll make sure we do our number line here. Oh, and it's less than or equal to 9/4. So 9/4, we're going to color that in and it's less than. Okay, then over here, again, we're going to multiply through by the 6, just like we did on the other side. And 3 goes into 6 2 times. And then the cool thing about the absolute value is you're essentially doing the same steps twice. So 4x minus 10. So again, to solve for x, we're going to add 10 to both sides. 4x equals greater than or equal to 11. We're going to divide by 4. So x is greater than or equal to 11/4. So we're going to have 11/4 shaded in circle, and it's greater than or equal to, so we're going to shade to the right. And last but not least is number 70. And then that rounds out everything that we need for our first test. So let's look at number 70. I thought this would be a fun one. It says wavelengths of light. When white light from the sun passes through a prism, it is broken down into bands of light that form colors. The wavelength V in nanometers of some common colors are here. So when the wavelength is shorter, blue, green, yellow, and then when the wavelength gets higher, it's red. So it says when a fireworks display made of copper is burned, it lets out light with wavelengths V that satisfy the relationship here. The absolute value of the velocity, the wavelength V minus 455 is less than 293. Write this inequality without absolute values, find the range of possible values for V, and then using the preceding list of wavelengths, determine the color of that copper fireworks display. So we have our equation written here, and it's a less than. So this expression is going to be between a -23 and a +23. And we're solving for V, so we're going to add 455 to all three terms. And so we get 432 less than V less than 478. So let's see what color that is. 432 to 478. 432 to 478. So we're in between the blue, so it must be blue. That's cool. Blue. I'm going to write it with my blue pen. Cool. That rounds out all of the lessons that you need for the first test. That's going to cover chapter 1 and chapter 2. I will be getting back with you on what materials you need to review for that. And have a great day. Yeah.